Bismillahirrahmanirrahim. So in this video we start with Bernoulli trial. A Bernoulli trial involves performing an experiment once and noting whether a particular event A occurs. The outcome of the Bernoulli trial is said to be a success if event A occurs and a failure otherwise. So it is very simple. You have just suppose you have just flipped a coin, and if you are interested in head, so after flipping the coin, the upside is head, then you will call it success. Otherwise, you will call it failure. The probability of achieving success k in n number of trials is given by the binomial probability law, which says that p and k is equal to n is the number of trials and k is the total number of successes or objects you want to pick, and then probability p raised to power k, 1 minus p is the failure, and raised to power n minus k, and this n choose k is equal to n factorial divided by k factorial n minus k factorial. The binomial is a type of distribution that has two possible outcomes. That is why it is called binomial. Bi means two. For example, a coin toss has only two possible outcomes, heads or tails. K is the total number of successes and P is the probability of success. So first of all, we look at an example to understand this binomial probability. BR, bit error rate of a communication channel, is 10 to the power minus 3. The transmitter transmits each bit 3 times, and a decoder takes a majority vote of the received bits to decide on what the transmitted bit was. So suppose a transmitter transmitted 1, the value of the bit is 1, and the receiver receives 1 1 1, then it will decide that the transmitted bit was 1, so the receiver will decode it as 1. But suppose 1 was transmitted but the received bits are 0 0 1, means 2 bits have flipped, 2 transmissions have flipped. So in that case, after 3 transmissions, the decoder or the transmitter will decide that the transmitted bit was 0. So here it takes the majority vote or the majority of the bits. The receiver can correct one error but makes wrong decision if 2 or more bits change during the transmission. So what we have to do, we have to find the probability that the receiver will make an incorrect decision. Transmitting the same bit 3 times is like repeating the experiment 3 times. Hence n is equal to 3. So first of all, we have to decide the values in this equation. N is the total number of trials. So here the total number of trials is 3. N is equal to 3. And as we know that k is the total number of successes. Now we have to determine k, since the decoder is based on the majority of vote, and we have to determine incorrect decision or the error in the detection. At least 2 bits must have flipped during the transmission. So what is success in this case? Actually, first of all, we have to understand what is success and what is failure. Success is the thing what we are observing in the event. Here what we are interested in the question. Our interest is to find the probability that the receiver will make an incorrect decision. Means 1 was transmitted, but the transmitter thinks 0 was transmitted. How is it possible? There is only one condition. If suppose 1 was transmitted but at least 2 bits have flipped, then the receiver will assume that 0 was transmitted. However, this is wrong because 1 was transmitted. But if only 1 bit flips out of 3, then still the receiver will make the correct decision. It will assume that 1 was transmitted, and this will be correct because actually the 1 was transmitted. So in this case, k must be greater than or equal to 2. Here the success is the error in the bit, because we have to determine number of incorrect bits, which is p is equal to 10 to the power minus 3, as it is given over here. This is the bit error rate of the channel. So we just plug in these values. We know that n is equal to 3. For it says k is greater than or equal to 2, so we have to take all the values of k starting from 2 up to whatever the limit is. In this case, since we have got only 3 bits, so in that case the it will be k there will be 2 values of k, 2 and 3. If we had 4 bits, then k would be 2, 3 and 4, but in that case n will also be 4. So first of all, 3, choose 2, p square, 1 minus p, 3 minus 2, 3 is n and 2 is k, and we just plug in these values over here in this equation, and when we get the probability of incorrect bits. So if we have got bit error rate is 10 to the power minus 3, in that case the chances of error in the detection of the bit is 2.998 multiplied by 10 to the power minus 6. There is another example. Suppose 80% of people who purchase pet insurance are women. If 9 pet insurance owners are randomly selected, find the probability that exactly 6 are women. So the probability is given that 80% women purchasers of pet insurance are women, and we have just randomly selected 9 owners, and now we have to see that out of these 9, exactly 6 are women. So p is equal to 0.8, n is equal to 9, and k is equal to 6. Again, we simply plug in these values in this equation, and we get the probability is 0.17617. A binomial experiment can have 2 outcomes, whereas a multinomial experiment may have multiple outcomes. Now we are talking about multinomial probability law, and the equation for or formula for multinomial probability is little bit different. Here we are just talking about this n factorial divided by this k1, k2, k3 up to km factorial multiplied by the probabilities is to the power k1, k2, k3, and k is the number of time an event occurs. The binomial probability is the special case of multinomial probability, where m is equal to 2. A dart is thrown 9 times at a target consisting of 3 areas. There is a dartboard on which we have got 3 areas, and dart is thrown 9 times. There are 3 areas on the dartboard, and probability of a dart to land in area 1 is 0.2, in area 2 is 0.3, and in area 3 is 0.5. Find the probability that the dart lands exactly 3 times in each of the areas. So first of all, to determine the number of trials, total number of trials, is easy because it says that a dart is thrown 9 times, so n is equal to 9. The event is that the dart lands exactly 3 times in each area. This is what we are interested in. So event is what? Event is that the dart lands exactly 3 times in each area. Hence we have to find the probability of darts to land in A1 3 times, A2 also 3 times and A3 also 3 times. Here we are interested because for every area it is the same. We want to see exactly 3 times it has landed in the same area. It could have been different as well, but in this example it is the same. So K1 is equal to 3, K2 is equal to 3, and K3 is also 3 because K1 corresponds to area 1, K2 corresponds to area 2, and K3 is also corresponds to area 3. And these probabilities, P1 is 0.2, P2 is 0.3, and P3 is equal to 0.5. It also corresponds to the respected areas. So we simply plug in the values in this equation and we get the probability is 0.0536. Another example is, suppose we have a bowl with 10 marbles, 2 red marbles, 3 green marbles, and 5 blue marbles. We randomly select 4 marbles from the bowl with replacement. What is the probability of selecting 2 green marbles and 2 blue marbles? So here the experiment consists of 4 trials. As it says, we randomly select 4 marbles from the bowl, so it means the total number of trials is 4, or n is equal to 4. The 4 trials produce 0 red marbles because here we are saying what is the probability of selecting 2 green marbles and 2 blue marbles. So it means that we are not talking about red marbles at all. We are not interested in red marbles. So the 4 trials produce 0 red marbles, 2 green marbles, and 2 blue marbles. So K1 is equal to 0, K2 is equal to 2, and K3 is equal to 2 also. On any particular trial, the probability of drawing a red, green, or blue marble is 0.2, 0.3, and 0.5. So this probability, how did we get this probability? We simply, we know that we have got 10 marbles, so we simply 2 divided by 10 is equal to 0.2, 3 divided by 10 is equal to 0.3, and 5 divided by 10 is equal to 0.5. So we simply plug in these values in this equation and we get it is 0.135. Geometric probability law. Consider a sequential experiment in which we repeat independent Bernoulli trials until the occurrence of the first success. So what is geometric probability? We keep doing the trials. I mean, we repeat the trials again and again until we do not get the success or the observation in which we are interested. So what is the example of such experiment? For example, I want to get head of a coin, so I keep tossing the coin again and again until I get a head. If I for example, I flipped the coin, I got tail, then I will flip it again, I will flip it again until I get head on the upside. So the probability PM is found by noting the failed trials before the mth trial. So what's the equation for that, formula for that one? Very simple. 1 minus p, which is of course in this case failure, raised to power m minus 1 multiplied by p. The probability that more than k trials are required before a success occurs is equal to Pm is greater than k is equal to failure q raised to power k. So here what we are interested in is that we want to know that how many trials, at least how many minimum number of trials will be required to get the success. So you can get that thing by using this equation over here.